Welcome back, team. At this point in our study of series, we are going a little bit beyond where we went in IGCSE. Last time we talked about sequences, for example, 1, 3, 5, 7, 9. This time we're talking about a series. Now, a series is a sequence where you're adding each term onto the next one. You can find this on page 116 of your textbook. So a series is when you are adding terms of a sequence. There are different types of series. Some are finite and some are infinite. I'm going to go through some examples with you. So we usually use this sigma notation that you can see I've got here in 1b. The sigma means sum of, and you're starting with a value of r equals 1 and you go all the way up to r equals 7, and you insert those values of r into the formula here. So the first three terms are going to be 2 to the power of r, which is 1, so 2. And then I'm going to add on to that my next term, which is going to be 2 to the power of 2, which is 4. And my third term, which is going to be 2 to the power of 3, which is 8. My last term is when I get to this number here. I started at 1 and I go all the way up to 7, so my last term is going to be 2 to the power of 7, which is 32, 6, I think it's 128. Now, the nth term is simply 2 to the power of n. Okay, let's move on to the next one. Sometimes we've got to work backwards. We're given a series and we have to put it in sigma notation. So you can see here we're adding 3 each time. So you know that it's going to be a 3n series. It's going to be 3n minus 1. So to put that in sigma notation, we're adding all of these terms of the sequence. We are starting at r equals 1. So it'll be 3r. And we're going to, you see how we've got these dots here? That means we're doing this series to infinity. So this is an infinite series. Let's look at our next series. Well, we notice that we're going up powers of 4, in powers of 2. So it's going to be something like x to the power of 2 r, because r is 1 here and we get 2, r is 2 here and we get 4, r is the third term here and we get 6. Okay, so it's going to be something like that, but you notice also that we've got this nasty little change of sign here. We've got some pluses and it's alternating between a plus and a minus. And if you look at one of the examples in your textbook, I think it's example 4, they show you how to account for this. So in addition to this, we need to have a minus 1. And when do we want it to be negative? We want it to be negative on the odd powers. So we're going to put this to the power of, on the odd term, sorry, to the power of r plus 1. Let's just see the effect that that has. Yes, that will work. This will give, in our first term, 1 plus 1, we'll square this minus 1, which will give us the positive x squared. When we get to our second term, 2 plus 1 will give us minus 1 to the power of 3, which will give us a negative here, so that's fine. Now we just chuck in our sigma. And what are we starting at? We're starting at r is equal to 1. Now notice here at the end we don't have any dot dot dot, which means it's not an infinite series, it's a finite series. And we're going to r 1, 2, 3, 4, 5, 6. So I'll write 6 up here. And that is my final answer for this. Have a go at these questions, see how you get on. Take care.